Okay, so I'm Naomi Hunter. I'm the CEO of Floating Home. We build electric canal boats. And if I click this, there we go. So we have designed a brand new hull. The entire reason for doing so was to make sure that it worked as efficiently as possible with electric propulsion. So we were lucky enough to go right back to the drawing board and work alongside a naval architect in order to do so. Our company's whole ethos is the idea of fusing technology and artistry together in order to create something that's not only beautiful, but also practical. And in order to do this, I took the approach of building a team of specialists. So I went out and headhunted the best of the bunch that I could possibly grab my hands on, and have formed what I think is quite a phenomenal team. So why we went around and did this was because I think that environmental stability is extremely important. We all live on this planet, and it's about time that we start to look after it. So if there are small changes that each of us can make in order to do this, I think it's really important that we do. So we've optimized for electric propulsion, as I said, and the whole point was to make this as environmentally friendly as possible without making it difficult for anyone that's living on them either. I'm going to hand you over to Alistair right now, who is our naval architect and a fellow of the Royal Institute of Naval Architects. So here he is.
Thank you. Good morning. I hope you can all hear me as well. Thank you for coming. It's nice to see so many faces here. We started this project really with, as we normally do, a completely clean piece of paper with the objectives laid out, so that we're not trying to fill it in with a preconceived engineering solution. And the starting point obviously was to try and make the hull as efficient as we can in order to minimize power consumption from a limited resource, really, in terms of the battery pack. That on its own is not enough, actually, because the hull itself is part of something else. It's actually providing an environment in which to live and possibly in some cases work these days. So we didn't want to produce a hull that reduced the volume inside it, or indeed minimize external spaces, which to us I think are quite important, aren't they? Because we go to the canal system in order to be in the countryside more than anything else, rather than be inside a closed box. So external spaces for us were quite important. So we've managed to retain quite large open spaces for entertainment. This is partly as a result of the hull form itself, as you can see here, has a different bow form on it, in that, I don't know whether the point is there. So we have an elliptical bow rather than a bow that comes to a point. And the reason for that really is to increase the volume forward. It also, funnily enough, reduces the bow wave that we generate at the sort of speeds that we operate. And if you think about some of the big bulk carriers and VLCCs that potter around the planet, we're operating at the same sort of speed range, funnily enough, in terms of hull lengths. And they also have big cylindrical bows and produce very little in the bow wave. You produce a pressure wave, but it disperses very quickly. So the small changes that we're making in terms of improving hull form are looking at vortex generation, really, because every time you create an eddy or a vortex, you're losing energy somewhere, because something's got to have energy's gone into it. So we're producing a hull which has got very gentle forms on it, so very gentle shapes, and not a lot of change in shape in terms of from, I suppose, port to starboard, if you like. The hull itself, as you can see, produces a very flat wake, and I'll show you on a slide in a minute that the difference between the wake in particular, this around the stern, the difference in the patterns between this one and a conventional boat with a standard swim on it. Oh, I'll go back. The foredeck, the benefits of having an elliptical bow in terms of the usable space are that we generate this really rather nice external space. So this foredeck is the same length between the stem head and the front of the cabin as you would find on a standard narrowboat. And yet we've got, as you can see, a herd of people on there, some of whom have got a drink in their hands. And underneath, of course, we can put quite a large freshwater tank. So on this particular boat, which is a 62 by 9'3", there's 1.5 tons of fresh water under the foredeck. Most of our focus was around the stern in order to improve propulsive efficiency. A propeller is at its most efficient if there's nothing in front of it at all, but of course that's not much point in that because you're trying to propel something. So what we tried to do here was to minimize the effects of having the boat in front of you. So we have a swept stern which runs, the sweep runs quite far forward but doesn't actually impact on the space inside. So it's a very gentle curve, so we're accelerating the water very gently, so not putting a lot of energy into the water to move its direction. And the pod in which the motor sits, if it'll come to that. Oops. We'll get there in a minute. There we go. So it's a very, very slender pod, and we're able to do this, of course, because we were fitting an electric motor, and they tend to be quite small pieces of equipment, delivering quite a lot of power. And the photograph on the center there shows you just how little there is in front of the propeller, providing a blockage. So what we're providing in terms of water flow into the propeller is nice, clean, non-turbulent flow, which propellers like very much indeed. You'll note that the rudder itself is slightly different as well, but I'll come back to that in a minute. This slide is quite interesting because it shows the wave pattern difference between, so waves are what are generated by a body moving through the water. And although the sections around the bow, the wave patterns around the bow are not. So this is the standard hull that you would find on a standard narrowboat, and this is our hull. The wave patterns around the bow are very similar, but what the big difference is around the stern here, where you can see there's quite a big amount of turbulence behind the standard narrowboat. The differences in reality are not massive. So we would save something like about 1/4 of a kilowatt on drag. But it's significant in real terms because that's probably around 10 to 12% of the drag of a hull, and over a period of time, this becomes quite significant. Having the bow section actually adds a little bit more as well, and you can see there the difference in powering on between a 57 narrow standard and where are we in kilowatts? So it's about 1.8 kilowatts to drive our hull and 2.1 odd to drive a standard narrowboat. So it is actually, to my mind, a significant improvement, but without actually detracting from the use of the boat, which I think is really important. So back to the rudder. All of our boats all have flat plate rudders, and the reality is that they stall at very small angles of attack, somewhere around about 15 degrees. And after that, all they're producing is turbulence off the lifting edge, which is just throwing energy away, if you like. What you're really after is something that produces nice, smooth lift and no turbulence after it. And what we have here is a fairly short rudder because we haven't got a lot of depth with end plates on it. Now, the effects of the end plates are that on a standard rudder, as you look at the pressure difference between the lifting surface and the pressure surface towards the top and bottom of a rudder, you'll find that it tapers away because we've got tip vortex, tip flow running from the high pressure side to the low pressure side, which reduces the amount of lift you have. If you put end plates on it, it actually makes the rudder think it's twice as tall as it is. So it improves the efficiency of the rudder remarkably. The nice thing about this is that this particular rudder form doesn't stall until you get to 70 degrees of helm angle, which is enormous. And the net result of that is that you get the propeller wash coming off pretty much parallel to the transom when you've got it at 70 degrees, which makes the boat extremely maneuverable. So you can actually turn a boat on its axis, which is quite a nice feature to have. We went for electric propulsion for all sorts of reasons, one of which Naomi's already mentioned, which was we're looking to be a lot more sustainable and consume a lot less in the form of energy. Driving a conventional boat with a relatively large diesel engine is incredibly inefficient. Diesel engines like to run at their most efficient under about 80% load and above, so that they've got the thermal efficiency of the heat in the chamber. If you're running them at tick over, the efficiencies drop down to 8 or 10% in terms of the fuel consumption, which is not really where we need to be. And in particular, there's a considerable amount of unburnt fuel and other noxious fumes in that. So diesel propulsion, from my perspective, is not really the sensible way to go unless you fit a particularly small diesel engine of around 5 or 6 kilowatts. And I haven't seen any narrowboat that's fitted with an engine that small, I'd say. So we've moved away from the diesel engine for a number of reasons, that being one. The second is they actually introduce noise. And the third is actually you've got no control below tick over speed. So if you want very slow speed control, you have none other than jumping in and out of gear. So electric motors offer an enormous amount in terms of all these little small things that can make a difference. One of those is you can run these motors down to 2 or 3 RPM, which actually means that you can trickle into somewhere quite nicely without actually having to jump backwards and forwards on the throttle. So all these nice little small changes. They are a lot smaller. They are extraordinarily quiet, and we've gone for a Voltsport motor, which is an AC synchronous motor, which is water-cooled, very nice, very, very small, direct drive, which I like because we can then run without the gearbox or drive any form of auxiliary drivetrain like tooth belts and so on, all of which introduce further losses. So we're nibbling away at all these little bits to make sure that we're not throwing away energy that we don't need to. The benefit also is that it being quite small, it means that we can make our pod in front of the propeller as small as we can. And in fact, we have the ability to make that probably even a little bit smaller if we wanted to move the engine a bit. We've put the motor where it is so that you can still get into the engine room and stand there, which is another one of these small things that we need to think about how the boat is being used. And part and parcel of being able to use a boat is to make sure that all the equipment that's on there is get-atable and maintainable. So a lot of the bits and pieces that would need maintenance are all pulled back into the engine room. So we have no mechanical systems inside the boat itself, inside the cabin, other than the shower pump-out pump, which we've cited where you can get at it. So we also like going for an electric motor because you can run we're running our propeller somewhere between 280 and 600 RPM to get the best efficiency out of that. So it's slightly larger, slow-speed propeller, so it produces less velocity in the propeller wash, which is quite good for reducing riverbank erosion and so on. It also means that you've got a lot of punch in terms of thrust. So if you think about tugs and so on, they all run very large, very, very slow-running propellers, and they do that because they can get a lot of thrust out of it. So that's part and parcel of that mix of channeling those bits of knowledge into that. So those are those points covered. I think the engine room itself is quite interesting because where you've got such a small power plant, and we have this different stern shape, it gives us quite a lot of improved volume in the aft end, where you have the machinery space. So we've actually got room to put a generator with room to get all the way around it, including getting at the exhaust system. We've got room to fit the hot water cylinder, all of the pumps, and the battery bank, which in our case we use either lead acid or preferably lead carbon battery banks, which have large volume. So that's all in that same space, without actually making it such that you can't get to anything. I'm going to pass you back to Naomi now to talk you through some of the other things that we've thought about whilst going through this process. So here we go.
Okay, so as you can see, all of the changes that we've made, not that big, but very, very big impact when all added together. So with that in mind, we've also added other tiny features, things that people could probably do on their own boats. So it's not something that we're just talking to you about the only things that you can do or what's on ours. So for us, with the propeller, with the fact that we've got such a fine pointed flow of water, we then thought about the issues that may occur due to that. Things such as fishing lines, weeds, always getting tangled around, right? Worst thing that can happen. So on our propeller shaft, we've automatically put in weed cutters because there's nothing worse than having that moment you're going along and automatic halt stop. So we put those in to help prevent stoppages of our propellers, which also then impacts the fact that we're continuous moving, and if you have to stop and start, that's an extra use of energy, right? Alongside that, we've also done things such as you see here, we've got the GRP weed bung. Most of us on our canal boats will have a solid steel top, and I don't know if you've all had it, but I definitely have, where you're using a spanner and it takes the skin off your knuckles. Fed up of that. So we thought, GRP weed bung, not only does it sit as a bung would all the way flush with the bottom of the boat, which means that we don't end up with small vortexes of water coming through and creating air bubbles underneath the boat's hull. It also means that as you go to lift it, it comes out extremely easily, super light, which means that you can maneuver it through that engine space a lot easier than you would a flat plate of steel. We've also done things such as we've got stainless edging. So on all of the edges where your ropes would lead, we have fair leads on ours like you would find on a big ship. On all of those edges, we've put stainless steel because those are the edges that your paint's going to chip on if it's going to chip. And that means that it's going to prevent that chance of rust, which also then protects your investment in your boat. Because at the end of the day, you get a small patch of rust, there's a chance for it to become bigger. So we've gone with those. All right, next one. So we've done extra details, such as we have a step into the machinery space, where our machinery space is quite spacious and you have the opportunities to move around it. We thought, take that a step further and have yourself an easy access in and out, because if you're taking toolkits down there, you don't want to be hauling them around and lumping them in and out of the space. We also put stairs onto our roof, because as anyone will know that's tried single-handing, there's nothing worse than trying to hop up onto the roof, grab a rope, all whilst you're in a lock, everything's going a bit manic. So we thought ease of access to help with that. Also, you can get up and down without putting your gin and tonic down. Stainless steel hand grabs. So as we all know on the cut, you could be tying up at any height of bank. So you could be jumping on and off your boat at any height. And there's nothing worse than being able to do that and not being able to grab hold of the boat at the height you want to. So our grab rails run to much taller than your roof, and they run the whole distance down to the floor. So you can grab hold of your boat at any height, just to help with ease of movement. There are other extra details that we add in. I mean, you are more than welcome to come and swing by the stand and have a chat with us. But I think the main thing to take away from this is there are lots of small details. It doesn't have to be everything. You can start with something small. So be it after the show, we plan on taking our rudder system and actually putting it out for sale, because that is something that every single boat could use. We've all got a rudder. We're all pretty standardized on it. And if it means that all of us can steer a little bit better, surely that's a good thing. I am going to hand this over to questions. So if you do have any questions, can you pop your hand up just so that we can get the microphone round to you for the videotape? Thank you.
Thank you. Am I on? Just about. Yeah, kind of. Okay. Thank you. Thanks. It was great talk. I thought it was very interesting. It's nice to see some innovations, thinking out of the box. With respect to the rudder that's got the plates on the top and the bottom, you're saying that makes it more maneuverable. Does that actually, when you're cruising, in reality, mean that it makes it more less easy to stay in a straight line and more twitchy? In a way that if you had a small kayak, let's say, that was a short kayak, it would be great for stunts, but maybe not so easy on the sea.
Okay, that's a very good question, actually. The answer is no, it doesn't. It makes it actually easier to keep a straight line. And the reason for that is it's generating much larger amount of lift at very much smaller angles of attack. So you would only need to move the tiller very small amounts in order to generate course corrections. So actually it improves the maneuverability of your boat quite substantially, actually. The end plates are such a simple thing to do. They would actually even work on a flat plate rudder to some extent. but they just cheat the rudder into thinking it's bigger than it is. So you don't get these pressure losses across the top and bottom of the plate.
The propeller, have you tried any different types of propeller or different sizes? Because I've seen they used to advertise axiom propellers that are supposed to be very good, but they are more square propellers rather than the standard propeller.
No, we haven't. I am aware of those. The last time I checked, they were not available here in this part of Europe. Whether that's changed or not, I don't know. Yeah, they were. I think they've come from the US, and they were not available in Europe at the time that I looked, anyway. But no, we haven't. No, so it is a fairly standard propeller.
Really interesting. Love all the innovation, brilliant ideas. That's great. Sort of must be a multi-million-dollar question. Interesting running on lead-acid batteries, and how long would you expect to run? And would you run all day? And would you power them off, charge them off solar, or how does that? You know, with a car, you know, you have to keep stopping at services to keep topping the battery up and keep recharging. How does your system work, and how long can you run for?
Okay, that again a very good question. So our sort of standard battery pack would be around 28.5 kilowatt hours. So that's a 620 amp, 48 volt pack. On the lead carbon, I'll come back to, because lead acid I don't think is our favoured route, simply because they require a lot more maintenance, and when you're recharging them, the top off at the last bit of charge is quite lengthy, in fact. So they're not really ideal for our application. Lead carbon are a better option, in that first of all, in our canal boats we don't need space saving in particular, because we have this large engine room that we can hide them in. We don't need to save weight, so that I think our battery pack is about 870 kilos, so, which is quite useful because that's less ballast. And actually, in terms of charging rates, the lead carbon is slightly better. We would expect to get the boat that we've got running on trials for our first client here is a 62 foot by 9 foot 3 with a 28.5 kilowatt hour battery bank. We ran for an hour and a half in an estuary and used 12% of that battery bank. So that gives you a fairly good clue as to what you might expect out of a range. So you get a good day out of it. We fitted, our approach really was to fit a very small range extender diesel generator set. So it's 3.5 kilowatts for 4 kVA generator set. And that will cut in when you get down to about 50% and cut back out again when it gets to 80. So, and that's an option. You can choose to let that run or not, or you can manually start it and run it if you want. So there are choices there. We would also suggest, depending on how you would use the boat, fitting at least some solar, and the minimum would be probably about a kilowatt in order to run your domestic loads. But we'd go sort of 3 or 4 kilowatts would mean that you'd run that generator very little. I mean, a charge time for the lead carbon, if you depleted it completely, would be recharged overnight on a 16 amp supply. So such as you'd find in a marina, you'd be topped back up to full in the morning.
So you can have access to a marina.
Yeah.
What output would the generator be?
It's 3.5 kilowatts. Yeah. So it's similar to plugging into the shore. And the reason for going for a small generator, severalfold really. The first is fuel efficiency. So whenever that generator runs, it needs to run at least at 80% load in order for the diesel generator to run, for the diesel engine to run efficiently. And the second is to do really with fuel consumption. So fuel consumption, and also we don't need a big generator in order to run the boat. So, but ship's loads, for instance, washing machines and so on, we can run quite happily on a generator of that size. So there's no need, in my mind, to fit anything bigger. And if you run it in range, well, a lot of us have boats in marinas, which is great because we can stay plugged in from marina to marina. But if doing a lengthy cruise, I think with a combination of solar and this backup of a generator, I think you'd be there, you know. We got any more? Yeah.
Just on the batteries, the lifespan of the batteries, disposing of them when they're, or can they be refurbished? Cost of replacement.
Yes, I think it depends on which one you go for. If you go for the lead carbon, then we're looking at somewhere around about 3,500 cycles before they're done. But that's full depth of discharge, and we're never going to allow that, I don't think, with the use of this standby generator, the range extender. So I would say, you know, it's got to be a good 10 years, if not more. And the current cost for that particular battery pack is around £4,000. So it's significantly cheaper than using lithium. And a simpler technology, to be fair. Any more? No further questions? Well, thank you very much, and I appreciate you coming to have a listen to us. Thank you.